from space. First seen a mere 3 decades ago. Suddenly it was more stunning than we had ever imagined. We saw Earth as a planet, as never before. It was a dramatic new view that marked the beginning of an unprecedented search to understand the dynamic forces that shape our world. In the desolate ice fields of Antarctica, scientists hunt for fragments from space to find clues of Earth's origin. In the fiery cauldron of a Hawaiian volcano, they collect dangerous liquid rock that may reveal hidden mysteries of the Earth's interior. An oceanographer in space surveys a global sea far more turbulent than ever envisioned. Deep-diving submersibles venture into the greatest frontier on Earth to discover fantastic new worlds in the alien deep. We live in an extraordinary era of exploration. We have learned that Earth's surface is cracked and moving, that its continents drift relentlessly across the face of the planet. We have seen the unimaginable. Strange places where the sea floor is pulling apart and where new land is born from volcanoes under the sea. We have unlocked the history of Earth's climate to solve the riddle of its ice ages past and to glimpse what the future might hold. Our space probes have uncovered an invisible yet powerful energy driven by the sun, whose impact we are just beginning to fathom. We have traveled to other worlds to find lost secrets of Earth's history and wonder if life may have been shaped by collisions from outer space. Our Earth is a vast and complex system that has evolved over billions of years, yet a new force may now influence its destiny. We stand on the threshold of a great adventure, equipped with a new generation of technology. We will probe the Earth and beyond for an even more dramatic look at the planet on which we live. Join us now in the first of a new 7-part exploration in the rediscovery of planet Earth.
Annenberg Media.
Corporate funding for Planet Earth is provided by IBM. IBM is proud to support the innovative spirit of scientific inquiry that made this series possible.
For most of man's history, Earth was a frightening place. Strange, tortured landscapes inspired myth and legend. On the Pacific island of Hawaii, the volcano goddess Pele was believed to curse man by turning him to stone. Primitive people stood in awe of the magic forces surrounding them. The fury of a volcano is but a small clue to the awesome power that forms the Earth's surface, that creates and destroys and creates again. Not until the middle of the 20th century did scientists arrive at the most comprehensive theory about the real forces that shape the Earth. It was a revolution in scientific thought called plate tectonics, from the discovery that the Earth's rigid outer shell is broken into huge moving plates, and from the Greek tecton, to build. In this new view of Earth, the seemingly permanent mountains, oceans, and continents are but the ephemeral manifestations of a continual cycle of creation and destruction. And today, the exploration continues.
Jan, I'm Pete Palmer.
How you doing?
Nice to meet you. Looks like we got a really great day ahead of us.
Yeah, looks like a good one.
Pete Palmer of the Geological Society of America takes us to one of the world's great natural geological laboratories, a place where many chapters of Earth history are revealed. The Grand Canyon. "10 miles across, 250 miles long, a mile deep. But more important, it is a story of vast changes over vast time."
The Colorado River has exposed a spectacular window into the past. In the walls, we see the kinds of evidence that establish geology as a science. Evidence that the Earth has a long history, that it can be understood if we just know the rules. And rock layers are like pages in a book. The horizontal layers preserve a record of seas and rivers and deserts.
Pete Palmer descends ever deeper into the great time capsule of the canyon.
Underneath those horizontal layers, there's a tilted series that records an older record of seas and rivers and even some volcanoes. And beneath them, there are contorted vertical layers that represent the guts of an ancient mountain system.
Scientists can date each of these worlds because radioactive materials in the rock act as a kind of clock. The canyon records some 2 billion years of an Earth that has changed its surface many times. The Grand Canyon dramatically reveals that Earth is old and Earth is dynamic. Over time, whole worlds have been created and destroyed and created again. Just 2 centuries ago, these were radical ideas. Their acceptance began a major revolution in the scientific understanding of the Earth that continues today. The revolution began in Edinburgh, Scotland, some 200 years ago. In the late 1790s, the Industrial Revolution and the political revolutions in France and America were being felt around the world. This spirit of change inspired radical new ideas in science. In the dogma of the day, Earth was created by heavenly forces, and its surface shaped by the great flood of the book of Genesis. By counting lifetimes in the Bible, leading churchmen had pronounced that Earth was created precisely in the year 4004 BC, on October 26th, at 9 in the morning. The Earth was a mere 6,000 years old. But 18th century Edinburgh was a source of intellectual ferment. Among the geniuses of the now famous Scottish Enlightenment was James Hutton, the father of geology. Hutton spent a lifetime puzzling over the Earth. He would challenge, then change the dogma of his day. Sketches for Hutton's book document his keen observation of nature. Might the rock layers be different worlds, each with its own origin? Hutton scoured the crags of Scotland in search of clues that would tell how these worlds were formed. 18th century wisdom declared the Earth's landscape fixed and unchanging. But the extinct volcanoes surrounding Edinburgh aroused Hutton's skepticism. They suggested to Hutton a surface that was dynamic and constantly changing, driven by what he called the Earth's great heat engine. Gordon Craig is the James Hutton Professor of Geology at the University of Edinburgh. Here, on Edinburgh's ancient volcano, Arthur's Seat, and along the Salisbury Crags, he explores the rocks that told Hutton of a living Earth.
Wasn't it marvelous that Hutton should have this as his backyard, an old volcano? He used to walk here with his dog called Missy, and the detailed evidence that encouraged him in his theory of the Earth was right here. because here you can see evidence of rocks overlying each other. The prevailing view towards the end of the 18th century was that all rocks were laid down in water. Not so far as Hutton was concerned. Hutton believed that these rocks, actually this particular rock, was intruded into pre-existing rocks. It was a molten liquid that had come up from below as part of a dynamic earth.
But another radical idea, geologic time, was needed before this restless earth could be understood. Hutton wondered, how long must it take to wear down a whole mountain? Built in 200 AD by the Roman army, Hadrian's Wall stretches from sea to sea across northern England. Erosion relentlessly destroys the landscape, but Hadrian's Wall hadn't changed much in 16 centuries. Hutton recognized that mountains must take millions of years to wear down, not centuries. That Earth must be far older than 6,000 years. Radioactive dating now suggests an age of 4.6 billion years, 1 million times older than thought in Hutton's day. When a mountain wears down and washes to the sea, the ground-up mountain forms flat layers of sand and mud. Here at Siccar Point, Hutton found one set of horizontal rock layers, but beneath these were others, tilted on their sides. What force could possibly bend solid rock in this way? Gordon Craig explains.
I guess this must have been one of the most exciting localities Hutton had ever seen. He was in his 60s, it was probably his last geological excursion, and he came across really what was the essence of his whole theory of the Earth. Because here he realized that there were vertical rocks here which had once been horizontal sands and muds. They had been folded by immeasurably strong forces, they've been uplifted, they've been eroded, and on top, these much younger sediments have been laid down. This cyclicity of operation, of erosion and deposition, of old lands wearing away and new lands being formed, was the essence of his theory of the Earth, a dynamic Earth as we know it today.
By asking how these vertical rock layers could have formed, Hutton made one of the great leaps in mankind's intellectual history. The rocks told a story of an Earth that was both ancient and dynamic. In his words, with no vestige of a beginning, no prospect of an end. The theologian's 6,000 years became but a single tick of the geologist's clock. Our view of Earth would never be the same. In the century that followed, scientists would explore further than ever before. German scientist Alfred Wegener was at the vanguard. Rare footage of his final expedition to the icy heart of Greenland in 1930 still speaks of a time when much was to be learned in the far reaches of the Earth. Science here was a struggle against the deadly powers of nature. These rigorous expeditions would enlarge Wegener's curiosity about the Earth. Wegener conducted many meteorological experiments, but he was curious about more than weather. He was puzzled by glacial deposits in the tropics, by identical fossils on continents thousands of miles apart, by mountain ranges with the exact same geology, but separated by vast oceans. His curiosity drove him to seek an imaginative solution to these scientific puzzles. Like Greenland's sea ice, perhaps continents could also split and move apart. Wegener's bold leap was to reconstruct a world where the continents fit together. His sketches connected broken mountain chains and solved other unanswered problems. This single giant continent is called Pangaea, all lands. Though based on careful scientific reasoning, Wegener's ideas were dismissed as fantasy by scientists of his day. No force could possibly plow whole continents through the bedrock of the ocean bottom. Wegener died in Greenland, lost in the far reaches of a frozen wilderness. But his vision of moving continents would haunt the scientific world until new discoveries at the bottom of the sea revived his challenging ideas. In mid-century, global research, highlighted by the International Geophysical Year of 1957-58, provided new ways of looking at the Earth as a planet. Spurred by this global view, scientists would explore and map the ocean floor and collect data that would lead to the discovery of an Earth far more dynamic than ever envisioned. In the mid-Atlantic, scientists would discover a mountain range that mirrored the coastlines with summits reaching 10,000 feet above the ocean floor. The mountains wind 46,000 miles around the globe like the seam on a giant baseball. Split by a central rift valley and rocked by countless earthquakes, no scientific theory could account for these curious phenomena. For centuries, scientists thought the ocean floor was part of the original crust of the Earth, frozen in time when the planet cooled from a molten ball. But dredging brought up relatively young rocks and newly created volcanic lava. Surprisingly, no rocks were older than 150 million years. Sediment cores were plunged to the ocean bottom. Scientists expected the cores to read like an encyclopedia of the past, but billions of years were missing. Some 95% of Earth history was gone. Where did that history go? Why was the ocean floor so very young? In 1960, Princeton professor Harry Hess proposed an idea later called seafloor spreading. He supposed that molten rock rising in the deep valleys of these undersea mountains formed new seafloor and spread to each side as more new rock came from below. If so, an entire ocean floor could be created in 1 to 200 million years, a mere 5% of Earth's history. But lacking hard evidence, Hess called his idea geopoetry. Ironically, supporting evidence for seafloor spreading would be found on land, at the site of an ancient volcanic eruption. Here in the Owens Valley of California, scientists probing one mystery would serendipitously provide a way to measure the growth of the ocean floors. When lava cools, it acts like a compass, freezing in the direction of magnetic north. But in several locations around the world, frozen compasses were discovered that pointed south. What did it mean? Do rocks somehow reverse their magnetism? Or more fantastically, can the Earth's magnetic field change direction? Since 1956, Alan Cox of Stanford University and Brent Dalrymple of the U.S. Geological Survey have explored this magnetic reversal mystery.
Our idea was to collect rock samples from all over the world. We would look at their mineral content, the direction in which they were magnetized, and their ages, and compare these. If rocks were magnetized to the south because they contain peculiar minerals, then all rocks magnetized to the south contain those peculiar minerals. On the other hand, if the wild theory that the magnetic field had flipped was correct, we'd find that rocks from all over the world recorded this flip at exactly the same time.
Yeah, I'll see what I can find here.
For accurate testing, the scientists must find lava undisturbed since the eruption.
The reversal hypothesis was an exciting one to me because it involved the entire Earth. It was a global phenomenon. And somehow I thought it was just marvelous that the Earth's magnetic field might have reversed itself. There was no proof of that. It was just a hunch.
A diamond drill is used to obtain cores of lava. Back in the laboratory, they are dated and carefully measured to determine whether they are magnetized to the north or south.
Good, thanks, Brent. I'll shoot that.
Before the core is removed, Cox takes a careful note of its orientation by using a compass to sight on a known landmark in the nearby Sierra Nevada mountains.
Azimuth.
Such precision is necessary to later accurately determine the lava's magnetic direction.
Y-axis is 281. This looks like a pretty good place to set up the footscape, Brent.
The frozen lava compasses here at Big Pine, California, reveal that the Earth's magnetic field did actually flip to the south almost 1 million years ago. What causes the magnetic field generated in the Earth's fluid dynamic core to reverse is yet another mystery. In the years following, the scientists from California and their colleagues would drill and date hundreds of lava samples from around the globe. They would find that rocks of the same age, whether from Alaska or Africa, simultaneously record the same magnetic orientation. This led to the construction of a time scale of magnetic reversals that plotted these flips. By 1966, Cox's group would confirm 9 north-south flips in some 4 million years. The discovery was like finding the Rosetta Stone. By cracking its hieroglyphic code, archaeologists unlocked thousands of years of Egyptian history and culture. But the geologists who helped solve the mystery of magnetic reversals would not be aware that their reversal code would also unlock a rich and dynamic Earth history. For a decade, research vessels had been towing magnetometers across the oceans. Here, over the mid-Atlantic ridge, the readings revealed strange and mysterious magnetic patterns. But no one knew what they meant. The key to deciphering these curious patterns would come from another team of scientists at England's historic Cambridge University.
People often assume that, well, we sort of had the idea in the bath or while shaving. Well, not collectively, but one of us had the idea in the bath or while shaving.
Frederick Vine, a young student, would team with Drummond Matthews to analyze a detailed magnetic survey Matthews made in the Indian Ocean.
Made in, what, 62?
Which I brought back from sea in 62, yes.
Which you brought back, yeah, just a few months after I started as a graduate student, and basically gave me the job of interpreting that.
Most thought the pattern was due to magnetic and non-magnetic bands of rock on the sea floor, but Vine and Matthews studied the data carefully and reached their own startling conclusion. Could the stripes of the pattern be a record, frozen into new ocean crust at times when the Earth's magnetic field was pointing alternately to the south, then to the north? At mid-ocean ridges, hot rock surges upward, cools, and is slowly carried away as if riding a giant conveyor belt. Vine and Matthews theorized that newly created sea floor, like volcanoes on land, records the direction of the prevailing magnetic field and leaves a matching pattern on each side of the ridge. The remarkable match of the magnetic patterns on the sea floor, stripe for stripe, with the magnetic timescale developed on land, established the concept of seafloor spreading and also the rate at which the plates are moving apart. If Cox and Dalrymple had discovered the geologic Rosetta Stone, Vine and Matthews learned how to read it.
Yeah, that was really the point. That was really the point.
1968, a specially equipped research vessel, the Glomar Challenger, is dispatched to the South Atlantic. It drills sample cores on either side of the mid-Atlantic ridge. Analysis of rock and marine fossils brought to the surface shows that the seafloor grows progressively older the farther it is away from the ridge. Glomar's drilling would provide the first direct confirmation of seafloor spreading, nearly an inch a year. Geopoetry had seemingly become geofact. 400 miles southwest of the Azores, scientists prepare for an extraordinary adventure. The French submersibles, Siana and Archimede, with America's Alvin, will give scientists a first-hand look at a site of seafloor spreading. Dubbed Project Famous, the expedition into the deep began 4 years after man landed on the moon. Alvin sinks for 2 miles into a rift valley the size of the Grand Canyon. the scientists film seafloor cracks, evidence that the plates are pulling apart. Distinctive formations called pillows demonstrate that volcanic eruptions from below create new seafloor, similar to this pillow lava forming off the coast of Hawaii. The fires of creation burn under the sea. As this new lava and the rocks beneath it cool, they thicken to some 60 miles, forming the outer shell of the globe, called the lithosphere. Numerous shallow earthquakes are recorded along these mid-ocean ridges, still deeper ones at edges of some continents and under high mountains like the Andes and the Himalayas. These earthquakes reveal the lithosphere is fractured like a giant eggshell into some 20 huge slabs or plates. Here, the African plate, the Indian-Australia plate, the Pacific plate. This lava lake is analogous to how these plates float on a partially molten layer beneath the lithosphere. The continents don't plow through hard ocean floor, as Wegener's critics claimed, but ride like passengers embedded in these floating rafts. As they jostle for position, the plates interact in 4 ways. Some spread apart at mid-ocean ridges. Some grind past each other. Those carrying continents collide. Some slide beneath each other. This ceaseless movement builds the Earth's surface. For those who live on plate edges, the results can be devastating. This extraordinary film of an earthquake in Japan was captured in May 1983. But the tectonic drama begins in the 5-mile-deep ocean trenches that ring the Western Pacific. Here, the westward-moving Pacific Plate sinks beneath Asia, beginning a complex and violent journey back into the hot interior, a process called subduction. As a result, Japan is one of the most earthquake-riddled places in the world, coping with alien forces that invade at will. Tokyo alone has been devastated nearly once a century for the past 2,000 years. As the plate that was once Pacific seafloor dives some 50 miles beneath Japan, it begins to melt. From this subterranean destruction comes new land as hot magma rises to fuel Japan's many volcanoes. April 1973. An undersea volcano explodes off the south coast of Japan. Scientists from the Tokyo Institute of Technology observe the explosion. From this, new islands are born, created by the plate destruction in Japan's subduction zone. Japan has been called the land of living volcanoes. Its history, a chronicle of tragedy. Yet its people seem to know that their land owes its existence to volcanoes. With stoic resolve, their life goes on, as the Japanese have learned to live with this endless cycle of plate tectonic destruction and rebirth. Along the southern edge of the Asian mainland are India and the Tibetan Plateau, punctuated by the Himalaya Mountains. Here, 29,000 feet above sea level, fossils of ancient marine life are preserved in the rocks. They tell the remarkable story of another plate boundary where continents collide. More than 40 million years ago, the northward movement of the plate carrying India crashed into Asia, and the Himalayas were born. Sea rock on the leading edge of India was pushed to the roof of the world. Here, the former island continent is thrust under Asia, creating the Tibetan Plateau, the highest average landmass in the world. Today, the impact continues, pushing Mount Everest ever higher. So intense is the collision that for thousands of miles inland, the Asian continent is being pushed aside as if by a giant snowplow, creating powerful unseen forces that can strike without warning. The People's Republic of China is home to nearly 1 billion people. For centuries, the Chinese have attempted to predict earthquakes, but still, the Earth can surprise. These seldom-seen Chinese motion pictures record the city of Tangshan in northeastern China after the morning of July 28, 1976. Ravaged by a colossal earthquake, 20 square miles of the city collapsed in total ruin. As many as 750,000 people died, equivalent to the destruction of cities the size of San Francisco or Memphis. It was the world's most destructive earthquake in 400 years, born of forces more than 2,000 miles away, where India relentlessly drives into and beneath Asia in a dramatic display of plate tectonics. Another kind of plate edge is marked by the San Andreas Fault on the coast of California. Here, the Pacific Plate moves violently past the North American Plate. April 18th, 1906. In a single minute, the Pacific Plate lurched 20 feet northward along the fault, releasing energy that had been building for a century. The earthquake and resulting fires destroyed much of San Francisco. Today, California's San Andreas is among the most studied faults in the world. A specially equipped NASA jet allows us to see some of its most striking features from the air. Along central California's Carrizo Plain, the fault clearly marks the edge between the Pacific Plate on the left and the North American Plate on the right. Here, as perhaps nowhere else, a boundary between two plates is dramatically visible, the scar of a great tectonic contest, as the strength of rock of one plate is pitted against the strength of another. The fault extends from beneath the sea. It begins where Baja California has been split from Mexico, runs up on land, and splinters California in two for 1,000 miles. Despite popular misconception, California will not sink into the Pacific. Instead, it will slide ever northward. In 15 million years, Los Angeles will be a suburb of San Francisco. The Giants and the Dodgers could again be crosstown rivals. Today, the tectonic struggle continues. In cities like Hollister, forces are released slowly and without violence through the gradual creep of the plates. But in contrast, just north along lakes atop the fault, the two plates are sticking, each day building ominous stress. The San Andreas Fault runs through the San Francisco Peninsula, out to sea, and then skirts the California coast for another 300 miles. As scientists continue to monitor the state, the cities along the fault will continue to watch and to wait, asking not whether, but when and where. At the California Institute of Technology, computers model the Earth's interior to better understand the forces that keep the plates in constant motion. Geophysicist Don Anderson.
We've got no idea what drives the plates, how deep they go when they sink into the earth, how deep the continents extend, how deep mid-ocean ridges are. The basic fundamental questions of plate tectonics and geophysics in general, we just don't have the answers to yet because we've been busy describing the phenomena rather than having the information required to completely understand the phenomenon.
On the leading edge of research into this complex frontier of geophysics are Brad Hager and Robert Clayton. The worldwide seismic network records the thousands of earthquakes that rock the Earth each year. Like X-rays, they are a tool for looking inside the Earth. From these waves, scientists infer the density and even temperature of the deep rock. By using this data, Clayton has produced some of the first three-dimensional maps of the Earth's interior. These 100-kilometer slices show the dramatic variation between hotter regions in red and colder regions in blue in the subterranean layers called the mantle. These maps reveal an interior far more complex than we ever imagined.
Now we believe that convection currents in the mantle are driving plate tectonics. We believe that upwelling currents are what drive the plates. And we know that when the oceanic lithosphere gets very old, it sinks back down into the mantle. We don't know how deep these phenomena extend. Various theories have been proposed, but they're just theories until we actually have the raw data.
In another demonstration of computer modeling, Brad Hager simulates convection through a cross-section of the Earth's mantle. In this model, the solid rock of the Earth's interior, driven by radioactive heating, flows like a liquid over geologic time. Each cycle, taking a few seconds on a computer, actually takes 500 million years inside the Earth. A new frontier opens. Science is just beginning to understand James Hutton's heat engine that constantly reconstructs the Earth's surface. Kilauea volcano on the island of Hawaii, a powerful testament to the paradox of creation and destruction. Much of Hawaii's legend grows from this striking spectacle. The fire goddess Pele lives here beneath the molten flood. But for scientists, the volcano is a window on the interior. Like the Grand Canyon, it is a revealing geological laboratory. Located in the middle of the Pacific Plate, Kilauea is mysteriously thousands of miles from a plate edge where most eruptions occur. Hawaii is the youngest of a 2,500-mile chain of volcanic islands and undersea mountains that stretches west to Midway Island, then north along the submerged Emperor Seamounts. Geology reveals that the islands grow older the farther they are from Hawaii. What causes this unique chain of volcanoes to form in the middle of the Pacific Plate? In a remote area of the Big Island, scientists from the U.S. Geological Survey's Hawaii Volcano Observatory begin an unusual task. The lava of Kilauea holds a fascinating tale.
Let's see.
To unlock the story, geologists Ed Wolf and Tina Neal must capture the molten rock while it is still hot.
Right here. You got the glove? Rashid, can you come with the water in the can?
They are armed for dangerous work. In another age, they might have been knights riding forth against demons or dragons.
100, 300, 400, 450, 7.
Sure, sometimes I'm scared out there. Sometimes my heart beats a little fast. I'd be worried if it didn't. When I first arrived, I went through the evolution of being just frantic at walking on lava that I knew was 2 hours old, to being able to do that quite routinely. But we do take precautions and we are sensible out there.
back and get the asbestos glove, the white glove? Right behind you.
Time is crucial. As the 2,000-degree lava begins to cool, its chemistry begins to change. Telltale gases are lost, erasing secrets of its origin and composition. Water cools the lava, turns it to glass, and freezes its message in time. This is as close to the Earth's deep magma as scientists can get. Unlike volcanoes on plate boundaries, Kilauea's lava contains untouched primordial elements from a source 2 billion years old. Scientists suspect that Kilauea rides atop a stationary thermal plume they call a hotspot, with roots perhaps as deep as 2,000 miles into the Earth's interior. As the plate moves over this rising plume of molten rock, one volcano after another is built. Hawaii itself is moving off the spot. 19 miles south, a new volcano has risen 8,000 feet above the sea floor, still some 3,000 feet below sea level. Dubbed Loihi, it will be the next Hawaiian island in a long chain, striking evidence of the relentless drift of the Pacific Plate. The Mississippi River, site of the largest earthquake in American history, some 20 times more powerful than San Francisco's devastating 1906 quake. In the winter of 1811-1812, 3 massive quakes changed the river's course and altered the landscape for hundreds of miles. The earthquakes were centered near the Mississippi Valley town of New Madrid, Missouri, once envisioned as the gateway to the West. Today, New Madrid is a peaceful Midwestern community. But in 1812, it disappeared. James Craven, mayor of New Madrid.
Good spot to see where the old town was, because the old town is right in the middle of the river. Sometime after 1812, after the earthquakes, the channel of the river moved over and cut away into the town. So really the old town is right out there where you're looking. As a matter of fact, if you could just imagine another, say, 5 miles straight through there is Reelfoot Lake, and really is the only evidence of the earthquake. So, you know, there's not like any big cracks in the ground or anything to show people, and people do ask that question, you know. They want to see some evidence of the earthquake, but, you know, there's just nothing you can tell them except, you know, hang around, maybe you'll get in the middle of one of them.
At the Abasco Corporation, an engineering firm in New York City, Dr. Otto Nutley of St. Louis University and geologist Fred Snyder are exploring the mystery of the New Madrid earthquake by computer.
What we see here down the center of the map.
What caused this massive disaster hundreds of miles from a plate edge where most earthquakes occur?
And here's the city of New Madrid up at the Kentucky bend of the Mississippi River. John, let's turn on the 3 biggest earthquakes that occurred in the area. We've taken over 2,000 earthquakes that were recorded in this area from 1974 through 1983 and put them into the computer.
Each cross represents a single earthquake. Computer plotting of recent earthquakes provides unique clues to the past. 170 years after the massive quakes, the New Madrid zone is still alive.
One thing we can do is look at these earthquakes in 3 dimensions now to try to get a better idea of how deep they are.
The distribution of earthquakes outlines fault planes, longer and deeper than previously thought. Because great force is required to break and shear rock at such depths, it is these deep faults that concern the scientists.
And this is important because it helps us to understand how the fault is being reactivated.
600 million years ago, the North American interior was neither flat nor quiet. The continent was tearing apart along a great rift. Then it stopped. Time has healed the great gash. Today, increasing east-west compression on the fault zone may reopen the ancient wound.
And for the first time, this gives us a physical model of the cause of the New Madrid earthquakes, and it might ultimately lead to our ability to predict the earthquakes.
In the 1811-1812 earthquakes, few lives were lost. Today, some 7 states and 12 million people would be affected. Cities like St. Louis and Memphis are beginning to consider New Madrid's destructive past as they plan for the future. Elsewhere, another new frontier of continental tectonics confronts science. The famed Golden Gate Bridge links the Marin Headlands to the city of San Francisco. For tourists, it is a landmark, but for scientists, it is a footbridge to a foreign land. Bonnie Murchie, David Howell, and Davy Jones of the U.S. Geological Survey are pioneers of a revolutionary new theory about the assembly of continents called microplate tectonics. By studying marine fossils locked in the rocks of the Marin Headlands, they have discovered that the all-American city of San Francisco came from someplace else.
You know, I used to have a paleontology professor who used to say you should never lick rocks because you could get some kind of
terrible disease. I think we've all got it.
Primitive one-celled organisms called radiolaria thrive in the sea. Like myriad invisible plankton, their skeletons drift to the ocean bottom when they die, forming part of the sedimentary rock. Similar to opal and quartz in chemical composition, radiolaria are remarkable for their symmetry and delicate beauty. They have been likened to living snowflakes. An acid bath technique etches away the solid rock. Carefully, the harder shells are released to tell their amazing story, free from the bondage of 100 million years. The abundance and variety of these shells is a product of ocean temperatures and environment. From analysis of these once-living jewels, Bonnie Murchie can determine the age of a fragment of former ocean sediment, at what depth it was formed, and its probable geographical location in the distant past. Like archaeological finds, comparing these environmental artifacts tells of a rich history. The electron microscope reveals finer detail.
Could you go down to the next one in that row? Oh, that's good. I can see the
From an
pores on
object
that.
smaller than a grain of sand comes a provocative theory about the forces that shape entire continents. The fossils from the Marin Headlands suggest that the piece of land anchoring the Golden Gate Bridge was formed in the deep ocean several thousand miles to the south. Some scientists now believe that San Francisco was built from many bits and pieces they call exotic terrain, chunks of land that have migrated from somewhere else. While the Marin Headlands came from the deep ocean, Alcatraz Island and the city of San Francisco formed in the shallow margins of another continent, and Angel Island was born by a collision or in a subduction zone.
We now recognize that most of the material in this central strip actually formed in the ocean and has been accreted to the continental margin.
The exciting aspect is that the 10 terrains that we've seen in the San Francisco Bay region, the character of these terrains can now be shown to describe the distribution of terrains throughout Western North America. We have discovered up to 200 terrains, such that the continent has grown by at least 25%.
Deep oceanic rocks in Idaho, exotic micro-continents in the Canadian Rockies, coral atolls now atop mountains in Alaska. And in southern Asia, new discoveries hint that other great blocks of land preceded India in its headlong collision with Asia. An intriguing new chapter emerges in the story of plate tectonics. But exactly where these exotic terrains came from and how they got where they are now will challenge science for decades. The vast power of the computer has allowed Christopher Scotese of the University of Texas to reconstruct whole chapters of Earth's intriguing past.
My work is really a fulfillment of a childhood fantasy to invent a time machine and travel back in time. In effect, that's really what we're doing here, using interactive graphics to take a peek back into time and see what the continents and oceans were doing millions of years ago. It's really like a second voyage of Columbus, but this time it's a voyage in time and not a voyage in space.
Geological data about ancient latitudinal positions is processed to scientifically reconstruct the continents. Some 250 million years ago, the world was assembled in the giant landmass of Pangaea, much as Alfred Wegener envisioned it just 70 years ago. Africa and South America fit easily. North America overlaps, possibly because exotic terrains have since changed its shape. Many mysteries are solved by showing how the continents moved about the globe through ancient time. By rotating from the equator to the South Pole, it becomes clear why there is evidence of glaciers in the Sahara Desert. Africa was once located in a polar region, just as Antarctica is now.
I think one of the most important things we're learning by going through this exercise is that plate tectonics is a global process, and it affects a variety of other global processes, such as climatology, mountain building, and possibly even evolution.
This turtle is on a 1,200-mile journey. Each year, green turtles swim from their home along the coast of Brazil to a tiny nesting ground in the middle of the Atlantic Ocean. Their destination is a remote volcanic peak along the mid-Atlantic ridge. The barren rock of Ascension Island is the setting for one of the most remarkable dramas in evolution. Dr. Archie Carr, a zoologist at the University of Florida, has been studying green turtle migration for 30 years.
It's easy to see why turtles nest on islands. There are not many predators on islands compared to mainland shores. Down in Brazil, for instance, there used to be jaguars roaming up and down the shore. They would eat the adults nesting as well as the young and the eggs, and everything else there practically. Every other carnivore does the same. But the big question is, why do they go all the way out to such a distant island in the middle of the ocean? How did it ever evolve? Now I've come to understand that it wasn't under present geographic conditions. Plate tectonics has now given us a beautiful explanation of how this thing could have slowly been acquired without killing them all off as they made that effort.
As Africa and South America split, a succession of islands emerged, then disappeared as they moved away from the mid-Atlantic ridge. As the ocean grew wider, the distance to each new island grew longer. Gradually learned over millions of years, these hatchlings will swim much farther than their distant ancestors, and even farther than those who brought them here. If Archie Carr is right, plate tectonics may have shaped the genetic code of the green turtle. The drifting of continents may have programmed life itself. And so the search continues. To learn how Earth's internal heat engine drives the plates on their long journeys across the face of the planet. To discover the Earth's vast and complex history as revealed in the rocks. To investigate our living machine and its endless cycles of creation and destruction. And new tools and technology in space will allow us to see in new ways, to continue the rediscovery of planet Earth. But the more we learn, the more we want to know. The words of T.S. Eliot amplify the scientific paradox. We shall not cease from exploration, and the end of all our exploring will be to arrive where we started and know the place for the first time.
Annenberg Media. For information about this and other Annenberg Media programs, call 1-800-LEARNER and visit us at www.learner.org.